Hey class, this particular part that we're looking at here is really important. It's called the standardized normal distribution. Another name for it is the Z distribution. And this is on page N4. And we're going to take a look at this problem that we were just looking at the end of the last lesson, and that is what proportion of the class has marks less than 80? And the problem that we had here was that with a mean of 60 and a standard deviation of 12, then 80 doesn't fall on one of those dividing lines, the 72 or the 84, which would be 60 plus 12 plus 12. It's somewhere about 2/3 of the way between the two, but you can't interpolate and say it's exactly 2/3 because of the fact that this is a curved distribution here. And so you can't use a linear interpolation. So there's got to be a better way of handling this. And this is where we're going to use something called the standardized normal, or informally the Z distribution. Now, the formula that we're going to use is this guy down here to standardize an x value. So we turn an x value into a z value. Let me show you how this works here. We're going to take a look. I've shown you this page before on page N5, but these are the marks of the 50 students. And so over on the left-hand side, we've got, over here then, we've got the original values going from 34 up to 60, up to 90, pardon me. The mean turns out to be 60, which is your mu, and your standard deviation turns out to be 12. And the median, by the way, just as an aside, is also 60. This is a symmetric distribution. So what we've got here then is that the distribution is perfectly normal. That's actually the way that I designed it here. And so we've got the proportions which are shown here at the top right. So 60 plus 12 plus 12 plus 12 is 1, 2, 3 standard deviations, and then minus 12, minus 12, minus 12 going down. And we've got the proportions of 68.3%, 95.4%, and 99.7%. And that's shown over here. You can see the dividing lines that we have here. Now, what we do to standardize this is, suppose I was to take every one of these numbers and subtract the mean off. So that would give me this column right here, which is x minus mu. So 34 minus 60 is minus 26. And we could do that with every number down here. 61 minus 60 is 1. 90 minus 60 is 30. So what we've done here is we've taken the whole distribution and we've just shifted it to the left on a number line so that it's no longer centered on 60, it's centered on 0. So this middle picture is what we've got here. The thing to note here, though, is that if you were to stick all these numbers into a calculator or use Excel, this middle column here, you would end up with still a standard deviation equal to 12. And so what we've got down here then is we would have a mean of 0, but we still have standard deviations of 12. So 0, 12, 24, 36, and going down the other way. The same proportions as before. What if we took one more step, though, and we divided each of those numbers by 12, which is the sigma, the standard deviation. So minus 26 divided by 12 gives us minus 2.16. That's what we call a Z value. Similarly, down here, we've got, let's go to the middle here, 1 divided by 12. 1/12 is 0.0833. And then over down at the very bottom here, if we took 30 and divided that by 12, we would get 2.5. Now that 2.5 means that 90 is 2.5 standard deviations above the mean. And if you go back to the original up at the top here, you would see that 90 would be right in here. So I'm in the upper right here. And so we've got 1 standard deviation takes us to 72. 2 is 84. 3 is 96. 90 is halfway between those two, 84 to 96. Now, the area it's still a curved distribution here. So again, you can't just simply do a linear interpolation between 84 and 96 and find out what the probability is. But we've got tables that will help us with that. But the thing I want you to note then is that the Z values tell you the number of standard deviations above or below the mean a particular number is. Above, of course, if it's a positive number, and if it's negative, then it's below the mean. So 90 is 2.5 standard deviations above the mean. So the formula that we use here is this. Now, the important thing to know is that when we're calculating probabilities, of course we're not going to do that for every value in the population. We're not even going to do that with every one of the 50 numbers here. Well, I have done that to show you how the thing works, but practically you would only focus in on the ones that you're interested in. So in our particular case then, we're asking the question, what's the probability that x is less than or equal to 80? Less than 80. Less than or equal to less than 80, again, it doesn't matter. It's just the way the sign is going. What's the probability that x is less than 80? So down here, it's, I'm just going to change colors here to maybe a purple. So here's where 80 is. And so that is, it looks like it's right in here. So it's between 1.25 and 1.75 standard deviations above the mean. And if we go back to our original one up here and look at where 80 falls, 80 is right here, and so that's 1 2/3 of a standard deviation above the mean. So the Z value would be 1.67 because 80 is 2/3 of the distance between 72 and 84. Now I'm going to show you how that works with steps. But here's what we're going to do is we're going to go then to a normal table. And by the way, it's really important that you print out this normal table and you bring it to your exam. So the Z values here are, they go to 2 decimal places here. So you would round whatever you've got to 2 decimal places. But this is how you read them. Is if you go down here, you'll see, for instance, 1.0. And 1.00 is exactly 1 standard deviation above the mean. That 0.3413 is the 34%. Take a look at the upper right here. That is 34% is from 0 from the mean up to 1 standard deviation. And if you go back to the properties that we had of a normal distribution right at the very beginning, there's your 0.3413 right there. Okay, so that's 1 standard deviation above the mean. Now, we changed the original numbers from, instead of 60 and 72, we changed them to 0 and then the number of standard deviations above. So 1 standard deviation above is 1, and so there's 34% of the Z distribution from 0 to 1. Now, if we add on another 13% here, we'll get 2 standard deviations above, which is half of that 95.4%. I'm just going to get rid of those and go back to where we were. So back down here. We take a look at 2 standard deviations, we get this guy right here, and that's half of 95.4. 3 standard deviations, that's half of 99.7. So we're always dealing with half of the distribution. And the reason why we do that is because we've got 50% in the other half. And we'll show you how we use that later. So when you look up a number on the table, it only takes it to the middle. And then you can add on another 50% or subtract 50%. We'll see how that works. So what we've got here then is that a Z distribution, let me just go back here. This is what a Z distribution looks like, and it has a mean equal to 0 and a standard deviation equal to 1. All right. Let's see how we do that. So in our particular case, we're interested in the probability that x is less than 80. We're going to change that into a z value. So the probability of getting a z less than some, let's call it little z. I always draw my little z's this way, by the way. You'll see that. And so that little x, that specific little x, is going to be converted into a little z value. And the way that we do it is using this formula here. So we take our x, which is 80, minus our mean, which is 60, divided by the standard deviation, which is 12, and this is 1.67. That's our z value. And that means that 80 is 1 2/3 standard deviation above 60. That's what it means, okay? So we go here and we look up, and let me change colors now to maybe a green. We look at 1.6, and then we pick up the second decimal place here, 7, and the intersection of those two, so going along the 1.6 row and then stopping at the 0.07 column, we have is 0.4525. That's actually this area here, 0.4525. And so that corresponds to a 1.67. Now, the other thing that we know is that there's 50% right here. So if we were looking at all this area from here down, from 80 down, that's equivalent on a standardized normal or a Z distribution of 1.67 down. Add those together and you'll get 95%. So that's what we've got here. So let's formalize that. We're going to go through how to work through these systematically, and we're going to use the same procedure each time. There's going to be 5 steps that you're going to go through. So step number 1, determine the characteristics of the population, including the type of distribution. Example, is it normal? Is it binomial? And the parameters, in the case of the normal distribution, mu and sigma. So what we say here then is, for our particular example, x is normally distributed with a mean equal to 60 and a standard deviation of 12. Now notice the notation that I'm using here. So this n here says that it's normal. And then here's your mu, and here's your sigma. In some books, they'll actually put down the last one as sigma squared. They'll put down the variance. I think it makes more sense to put it down as a sigma because that's what you're using in your calculations. But that's what we're saying here is, and so let me write that out then. X, which of course, X is the marks of the students, the marks, is normally distributed. With a mean of 60. And standard deviation of 12. All right, so that's the first thing that we do. That's step number 1. Step number 2 is to draw a picture representing the probability to be determined. So this is the probability of the x's. I always put the mean in because you want to find out what side of the mean that you're talking about. And we're looking for the probability of 80 down. So we would write this like this. What is the probability that x is less than 80? And we're looking at 80 down, so we could shade this like that to show that it's from 80 all the way down. step number 3 is where we convert. So we're going to convert our x value into a z value. So we're going to use this particular formula here. And so in our case then, remember I said I draw my little z's like that. Z is equal to our specific x value minus mu over sigma. So that's going to be 80 minus 60, which is the mean, divided by 12, which is our standard deviation, is positive 1.67. And you can take that to 2 decimal places because the table takes it to 2 decimal places. Okay, so that is step number 3. I'm going to just redraw that in terms of 0. So a z distribution is normal with a mean of 0 and a standard deviation of 1. You don't need to write this out here, but that's what we've got. And so we've got 0 in the middle, and we're looking at 1.67 down. And the reason why it's a good thing to draw that out is that you just want to make sure that this picture looks the same as this picture up here at the top of the page. And they do, right? And of course, they're just sketches, and so we're a little bit off where the lines are and so on. But the pictures should match. If you ended up with a negative number and you drew it out, they would look completely different. And that probably means that you reverse the numbers in the numerator. And that's an easy thing to do when you're starting out in stats. All right, so that's what we're looking at, is the probability that z is less than 1.67. Let's write that as a probability statement. Probability that z is less than 1.67. So this was our original probability statement here, and now this is our new one. Now, the next thing that I've got here is a cases sheet that will help you to figure out how to do this. One thing I want you to know is that you won't have the cases sheet for your exam. However, I don't want you to memorize these. I want you to see the logic behind them. And so the cases sheet is put here then as just kind of an intermediary step to help you and understand how you read the table. But what I'd like you to note then is, well, which picture matches what we've got down here? And you'll see very quickly that it's case number 1. And case number 1 says that the probability that z is less than some value, which in our particular case would be positive 1.67, is equal to the table value for z plus 50%. And that's because the table value will give you this area here down to the middle. It'll give you that area right there from 1.67 down. And then we're going to add on another 50%. So it only takes it down to the middle. When we take a look at the picture, the table, take a look at that little picture in the upper right. All right, I'm going to erase all that because I don't want to mess this page up. All right, so this is a case number 1. And so we've got that a case 1 says that the probability that z is less than positive 1.67 is equal to the table value for 1.67 plus 0.5. All right, the next thing that we do in the last step here is we go and we look up the table value for 1.67. So we go to the table back here, and we're going to look at 1.67. Now, we've already done this one here. And so remember I told you to take a look at the picture at the very top here? It'll give you the area from 1.67 down to the middle, and then we're going to add on another 50%. So we look up 1.6, pick up the second decimal place, 7, and that takes us then to this number right here, which is 0.4525. And so what that's telling us then is this is 45% and this is 50%. So we can say that's 0.4525 plus 0.5 is equal to 0.95. So we would say that 95% of the marks are less than 80. Or another way to say it is that if we were to randomly choose a student out of the class, there's a 95% probability that that student would have a mark of 80 or less. Remember, we don't get hung up on whether it's less than 80 or 80 or less. Typically, we're dealing with large numbers of people, like number of people in Red Deer or something like that, or number of people in Canada, and so on. And these are continuous numbers here. So that's how we do that. And what we're going to do next is we're going to work through a whole bunch of problems. So I'm going to leave this particular lesson right here.